What if I told you we could make our favorite treats, cakes, cookies, all that good stuff, healthier, but without losing that amazing texture we all love? It sounds almost too good to be true, right? Well, a team of researchers might have just cracked a big part of the code. And believe it or not, their solution involves a tiny computer, a camera, and literally watching fat freeze. Okay, let's dive right in.
2.5 billion. Just let that number sink in. That is a staggering number. Well, according to the World Health Organization, that's how many adults around the globe are currently affected by obesity. And a huge piece of this puzzle, as you probably know, is the consumption of unhealthy trans and saturated fats, the kind that are in so many of our favorite processed foods. So this health crisis is really lighting a fire under food scientists.
So, here's what we're going to cover. First, we'll look at the food industry's big quest for a better kind of fat. Then, we'll get into a really tricky scientific problem. They call it a crystallization conundrum. From there, we'll introduce the hero of this story, the colorimeter. And we'll wrap up by looking at how this nifty little device could pave the way for a smarter food future for all of us. Okay, first up, the quest for better fat. The food industry has this huge mission on its hands. How do you replace those unhealthy solid fats, I'm talking about things like shortening and some butters, without completely ruining that creamy, satisfying texture that, let's be honest, we all love in our food? Well, meet the Oleogel. Now this is a pretty clever invention. Imagine trapping healthy vegetable oil inside this tiny, microscopic scaffold made of wax. What you get is a semi-solid fat that has the texture we want from traditional fats, but it's packed with much healthier fatty acids. People see them as a really promising alternative for pretty much everything, from cookies and cakes to even chocolate. But of course, there's a catch. The real magic of an oleogel is all locked up in this crystal network. If that network doesn't form just right, the gel gets unstable and can literally start to leak oil over time. And that, as you can imagine, is not very appealing and really limits how it can be used. So the bottom line is this: to make great oleogels, you absolutely have to control how they crystallize. And that leads us straight to the central problem. If you want to control crystallization, you have to be able to watch it happen, in real time. But as scientists quickly found out, watching fat freeze with the kind of precision they need is way, way harder than it sounds. So if you could see this whole process in super slow motion, this is basically what you'd be looking at. First, these little tiny seed crystals, they're called nuclei, they start to form in the liquid oil. Then these crystals start getting bigger, which makes the liquid look kind of cloudy. And finally, you hit this stage called supersaturation, where all the leftover molecules just rush to form even more crystals until the whole thing turns into a solid, opaque block. Every single one of these stages is absolutely critical for that final texture. And this is exactly where scientists were hitting a brick wall. The typical tools they have to watch this, like these super powerful microscopes, are just insanely expensive, really complicated to use, and worst of all, they can't give you live data from inside the temperature-controlled incubator where all this action has to happen. What the industry really needed was the total opposite: something cheap, easy to use, and able to report back in real time. So this is the very problem that a research team in India set out to solve. And their solution is this really ingenious device they named the colorimeter. It's a low-cost, smart, IoT-driven device, and it was designed for one specific purpose: to solve this crystallization puzzle. And the absolute genius of this thing is how stunningly simple it is. I mean, just look at what it's made of. It's built from simple, off-the-shelf parts. You've got a Raspberry Pi, which is just a tiny, super affordable computer, a basic camera, an LED light, and a temperature sensor. All of it is run by some custom software. It is DIY science at its absolute best, and it's fantastic. And using it is just as straightforward. A researcher just punches in the parameters for the experiment, sticks the whole little device inside an incubator with the fat sample, and hits go. The colorimeter then just sits there, patiently recording color and temperature data. It even draws a live graph so the scientists can see exactly what's going on as it's going on. Now here's where the smart part comes in. This thing is a true Internet of Things device. Using standard software, it's basically just a remote control program for computers. A researcher can connect to the colorimeter totally wirelessly. This means they can be sitting at their desk, controlling the experiment and seeing the data live from a device that's sealed up inside an incubator somewhere else. I mean, that is a total game changer.
So, the million-dollar question, does this simple little box actually work? Well, the researchers put it through its paces with some really rigorous tests to see if it could hold its own against that expensive industry-standard equipment. The whole principle behind it is just so elegantly simple. As the fat changes from a clear liquid into a cloudy solid, its crystal structure is changing. And this quote from the paper explains it perfectly. Those changing crystals interact with light differently, which causes, you guessed it, a measurable change in the sample's color. So the eye colorimeter is basically just a very, very precise observer of that color shift.
Okay, so first up was a color accuracy test. The team pitted it against a pricey commercial device using standard color cards. The score here is called delta E, and you can just think of it like a golf score for matching colors. The lower your number, the better. The expensive commercial device, its error score was over 20, but the homemade eye colorimeter, it was under 10 every single time. That's a massive improvement.
And if you're a visual person, here's what that looks like. The error for the big, expensive commercial device is that tall bar on the left, and the error for the little low-cost eye colorimeter is that tiny little bar on the right. Yeah, the results pretty much speak for themselves on this one. But what about actually tracking the crystallization? For that, the team compared their device's data to the industry's gold standard, a machine called a Differential Scanning Calorimeter, or DSC. Now, this is a hugely expensive, super sophisticated piece of lab equipment, and yet the data from their little eye colorimeter showed a strong positive correlation. It was keeping up with the big leagues.
And to really prove its real-world value, they used it to watch something we're all familiar with: butter. The eye colorimeter gave them a perfect play-by-play as it froze. It saw the whole process start around 21 degrees Celsius, it watched the sample turn cloudy right around 19 degrees, and it recorded that final switch to a solid, opaque block at 15 degrees. And these findings lined up perfectly with data from the fancy DSC analysis.
So, what does this all really mean? We started out talking about a global health crisis, and we ended up with this simple, smart solution built from parts you could buy online. By giving scientists this affordable, real-time window into the hidden world of fat crystallization, this clever little device could genuinely speed up the development of healthier foods for everyone. Which leaves us with one last big question. Could a smart camera and a simple algorithm really be a key ingredient in creating the fat of the future?